Hello all. In this session, we are going to discuss about another important package in for data science that is called Pandas. Okay, in the last video we have discussed about NumPy and we have done some hands-on over the NumPy package. Okay, so let me open the slide. Yeah, so Pandas is another package which is very useful for data analytics. There are there are different logical techniques and the data evaluation and the discovery we can do about the data. We can retrieve some information, we can provide some insights, or could conclude some of the decision making the decision making objective. So those things can be done with the help of a very useful package called Pandas. Very useful package. It is like a Excel in Python, tabular format. You will see your data in the structured way, and you can present it to your Python code to manipulate that, to use to prepare for machine learning, to prepare for data analytics, to prepare for applying some statistical modeling. So the Python is very good for data munging, data preparation and modeling, as compared to R, because R also has this the whatever is the core data structure of R is now available because of the Pandas for Python. Okay, Pandas is good for data analysis and modeling to be done within Python. It is a high performance, easy to use data structure for the data analysis. Okay, so high performance because underneath there is a NumPy used. So the Pandas is built on top of NumPy, and we have already discussed in the NumPy video about how better NumPy does compared to a traditional list or any other data structure, right? So Pandas is it is also a powerful package with respect to performance. Okay, so this is a Python package. It provides the built-in data structures which is used to manipulate and analysis of data sets. Okay, so there are two important data structures one should learn about for Pandas. In fact, there are three, but two are we are going to discuss more about, because that is something highly used, that is called series and data frames. Okay, you will be hearing this word. The third one is panel data, which may not be using now, but yes, series and Pandas data frame are commonly used data structures. A series is a one-dimensional NumPy array, and which contains the scalar values of the same type, right? Numeric or character or date time, whatever data type we are using there. So these are important, couple of important objects or data structures inside Pandas. Okay, so we can handle CSV, Excel or SQL or JSON type of files. We can handle the missing data, we can reshape the data, we can slice the data on the data frames, we can index, we can subset or merge or join or concatenate. So those many operations we can do, and we will do that practically. We will see how we can do with the help of Python code, and this is optimized for performance, because we are going to work with the huge data and performance is really important. So the data structures, as we have discussed, there are two data structures, that is series. One is series and the second is data frame. Series is one dimensional and data frame is two dimensional. Okay, data frame, to shortly understand in a simple way, is a dictionary of series, and series is nothing but a dictionary which is a one-dimensional dictionary of a list kind of thing, right? So where we see that there is a named list available inside your that is a dictionary, and that is termed as a series object. Okay, so that's how the series looks like and the Pandas data frame looks like. Yeah, so we will see some more details about the Pandas series and data frame with the help of some example. There are two primary structures which we have discussed in this session. Now we will see in this slide. Now we will see how we can use them, how we can in fact write onto the code. Okay, the very first thing we have to do is we have to import Pandas package. Okay, so pandas is the name of the package we can import, and we can use this for creating a data frame, and get your data. You can do some kind of a money manipulation there. Okay, so let me do some hands-on here. So I have data sorry I have one a Jupyter notebook. Let me open and import a pandas library. Okay, we can create alias as well, the same way we have done for the numpy earlier. So we have imported, let me also import that. I may use some time. Import numpy as np. Okay, so these are commonly used, a couple of libraries, very useful and very powerful libraries we have in hand, and I'm really excited how to use and how to make use of these libraries, because it gives us a lot about a file, about a data, about working with data quickly, right? So for example, I told you in one of the practice session how to use a TCS data set where we have a stock prices information, and we wrote some few lines of code to analyze and get the average closing price for each year. Okay, so such kind of small thing can be done quickly within 2 lines, 3 lines of code, compared to what we have done earlier, right? So this package is very useful, not only for such example, but a lot of files we can process, a huge amount of data we can take and we can manipulate. We see it clearly, it's easy to understand and learn. Okay, let's create a very basic series. Okay, pd dot series, pd dot series is the class name, and if you create a series, let's see how it looks like. Okay, this is of series object, and S is capital, that indicates it is a class. Okay, and S1 is the object we have created of type series. Okay, and if I print that, obviously it shows you like a column, right? A single column. So remember this 1 2 3 4 1 0 2 3 sorry 0 1 2 3. Okay, so these are the indices, right? There is an index given for each of these columns, right? So the actual data is 2 3 4 5. Okay, so that's how the series looks like, and I will take on one more example how we basically create a series even using a dictionary. As I said earlier, suppose I have let's say phone number. Okay, and I will put some number here. Okay, and let us try and see pd dot series of this particular data. Okay, so you got this ph, and you got one value associated with that. So you can perhaps have such things, more such things here, right? So maybe ct, okay, colon, you may have let's say Mumbai. Okay, so just I'm taking example. So you have it is like, now we got a keys and values kind of a structured arranged data, but this is a tabular format. Remember, series is a tabular format data. Okay, type, if you check, this is of type series, right? So we are not going to work a lot of with the series, but yes, we should know this is a basic building block of something called data frame, which we will be exploring more about. Okay, for example, I have one suppose I want to take one data frame quickly to understand how we can probably write something. So I will take a dictionary first, and let's say I have year colon let's say 2015, 2017, and 2018 and 2019. I'm just taking some years, and maybe I'm taking some attendees for a particular event. Suppose every year I will just capture that, maybe 345, then 456, 577, and 900. Let's just take some numbers, right? So once we have this, let's understand what data is and how it looks like, and obviously it is a dictionary, right? We don't have to discuss much about this. Let's create a data frame. Okay, df as the name I give, then pd dot data frame. Okay, and just give this data, and look what happens. Type df, it is a type of a data frame. Now if I print a data frame, you will see the data is arranged in a way where we can easily read and understand how it is it is showing to us, right? So this is the best part. This is how it looks like, and we can, for best thing about this is we can just check one column. If you want, you can take year, you can take attendees. Okay, the alternate way to do it is, you can access this way as well. Df in the square in the index operator, we can put that attendees as an index in the single quote, right? So the line number 13 and 14 are exactly same. There is no difference. Okay, it's just a matter of showing it this way or the other way. But sometimes the name of the column could be the name with some space also, right? In that time, perhaps this is not a good choice to use. Better we can put that two words inside a quote and display using this style here, line number 14. Okay, so that's how we can create. There are some basic operations we can do. For example, we can check the shape of your data frame. It shows me 2 by 2, 4 by 2. So very similar to what we have done with NumPy arrays, right? The total size, number of elements we see in the data frame, right? So you can check the indexes, right? What is the index here? So index starts from 0 and up to 4, not including 4, right? That means 0, 1, 2, 3 is the indexes, right? You can check here, 0, 1, 2, 3. So that is how we can access indexes to a data frame, okay, of the data frame. Okay, so I will be coming to indexes because we will now learn and understand how we can use index and slice some of the data from the data frame. So right, so I hope slicing you recall, we have done slicing for NumPy array, slicing for list, slicing for strings. So we can slice data frame as well, and indexes is useful for for that matter. Okay, so we can also get df dot values. Now if you look at the values, so the actual values is these are the actual values. Okay, obviously ignore this part. So these are the actual values. Okay, let me just show you once again. Actually these are the actual values out of your entire data frame. Okay, so the name here, year and attendees, so these things are the labels given, and these are indexes, but the actual values is 2015, 17, 18, 19, and 345, 456, 577, and 900. Okay, I hope you understand this. If you see that the output of this, just by doing dot values, what I get is a NumPy array, correct? So that means, let me try and say a equal to df dot values. Okay, and check type A and check what is the value. Perfect. So that means a data frame can be converted. Okay, a data frame is just converted to a NumPy array. That means just by checking the values, I am actually getting the NumPy array of all the values. Okay, it's a two-dimensional because the entire data frame looks like a two-dimensional. It's a table 2 by 4 by 2, correct? So that's how simple and flexible data frames or pandas is. Okay, now df.columns, there is also a provision to check the column names, right? Year, attendees. So I'm going to use each and every command what I'm trying again and again for at least couple of times in this session when we really work with one data frame which we want to try. Okay, df.info, another important function. Okay, these are all attributes we have used, and now I want to explore one function, right? So this function gives me some information about this particular data frame. Here it says that how many attributes are there. There are two, right? Year and attendees, and there are 4 values for each of this. Okay, and of type integer 64, integer 64, and that's right, I think, correct? Yeah, integer and integer. So that's the important function. We can check how we can use this. Now let me also take one more example to make you understand how we can have another different type of data frame. Okay, so I'll just create one more. Okay, colon a colon I can use, let's say 1, 2, 3, and some missing data we can do, right? So np.nn is a command, is a NumPy is not a value, that is a missing data information. We can use NaN. Okay, let's say this is 1, and I will use, let's say b colon 5 comma np dot nn comma say uh, 6, or maybe I'll use one more missing data here. Okay, and C colon, here I will not use any missing data. Let's say I have a simple data frame, data in the um, dictionary. Now I create a data frame out of this. Okay, we can create a data frame using data frame class. Okay, let's see how your data frame looks like. Yeah, this is what, oops, I think something went wrong. Yeah, I should have used this as a list here. Okay, so this is how your data is created, and you got one data frame. Now let me also help you understand this NaN is actually a missing information. Okay, so I will demonstrate you how we are actually doing, right? df dot to csv, there is a function which we can use to save this information somewhere, right? So we can save this particular data frame into a file. Okay, home gbure data test.csv. okay, I am saying, see, do you recall we have something called open function, that is a built-in function to write or to read files on the on your disk. Okay, we can read the text which is written in the file, that is ASCII file, and we can also write something into file when we open a file using write mode. Okay, the same thing we can do, but if you have a data frame, you have to convert it to it, the string, and then you have to write. Instead, we can directly write a pandas data frame into a tabular structure, or that is into a structured file name. Okay, it can be CSV or Excel, or you may want to write in JSON. So those are some of the options we may want to explore. Okay, yeah, let's see what happens here. Now let me open that, how you can see how it is saved. Okay, in the home directory, if I go, there is a data somewhere. Where is the data? I don't see data. Yeah, it's there, and there is something called test.csv. Let me open test.csv and see what happens. Look, so this is how your file looks like. Okay, there are columns and there are rows. Okay, A, B, C is the column name, and there are some indexes we have given. So the actual data is this. Okay, but you might have realized here there is something missing here, right? So that missing information is nothing but NaN. Okay, this information is missing, this is missing, and this is missing. Okay, if you read this contains again somewhere, so you will realize that, okay, this is how your data will be read. Okay, so let me open and help you understand. So this is NaN. Now a lot of times, even if you read such files, okay, sometimes you may find this the missing information. So maybe I will add something here. And I will add some value here. Okay, and I may be adding something more. Let's say 3 5 0 missing here, and let's say 6 again. Okay, I save this. Okay, just for our the next thing we will do, let's try it out here. Here I will take the same style I will use to read it, df2, let's say. Okay, then pd dot read csv. Okay, and let's try and see how we can read a particular csv now. Okay, and let's check if we were able to read or not. Okay, I don't use head. What went wrong? Why test dot csv, read csv, why we didn't get the other column? That's strange. Test dot csv, right? So did I do something wrong? No, right? Read csv, and the csv let me open it on the terminal, just a moment. Data vi test.csv. Yeah, okay. Okay, so by default there is a, okay, I think there is nothing wrong, but still I will remove that first. Okay, I will actually, I should have removed the indexes. Okay, I will tell you how to ignore the indexes. Okay, but for now let's try and okay, so these are the four values, these are four values. Yeah, here there are four values. Actually there is comma here, and here there is comma, here there is comma. Okay, I think maybe let's try this time. Oh, still I can't read that. How it is possible? Read CSV. We are reading this particular file. Oh, sorry, df2 I should have used. I'm sorry for that. So basically I was reading into df2, but I was just printing df. Okay, that was the mistake. Okay, so there was nothing required to change as such, but it's okay, now we have changed. I thought that was the problem, but that was not the problem. Okay, we can use Excel directly. Okay, whatever is the data present, we can directly use it, and this is what exactly we have, right, in our data in our Excel sheet, or that is CSV file. Okay, so many times we don't want to handle this, or we don't want to use this missing information, because missing is a problem, right? Sometimes it gives you some kind of a misleading information, right? So and may not be required. Sometimes we have to make sure that we don't have the missing information, correct? So for that there is a provision. When we do exploratory data analysis, at that time we will see how to process this missing information. Okay, but for now we can use some of the functions to use or handle this missing data. Just one second. So what I was saying is about some of the functions which we can use to sometimes we may want to drop, or we want to fill by something else, right? For example, df2, and I have suppose a. Okay, that is where I want to fill something. So fill na is a function, and wherever you find some missing information, you may want to fill 11. Let me see if it really does. Yeah, it does, right? So this is what it's doing, right? Wherever it finds na, and that is where it has added 11. Why 11.0? Because everything is floating point, so it will consider as a floating point. Even everything is floating point, because when you find at least one floating point, so the entire column or row becomes your entire column becomes a floating point. So now this is how we can fill up. Okay, let's check now. So strange, we didn't get that filled up here, right? That means this is not actually reflected into your data frame. So how do you do that? Dot a, or this one, this way if we write, and then if we check, yes, now this has done the way we are expecting. Okay, so that's one thing, right? The second thing is, sometimes we want to fill up with the information. Maybe we take the average values, or maybe we guess something, or maybe we predict something, or there are different ways to handle this missing information. We can definitely do that, but let's understand if there is some missing data which we don't want to fill up, but instead we want to drop that or ignore that particular information. Okay, so let's understand. There is something called info function, which we have just seen some time back. This info function gives you a little more clarity about what the data is all about, right? So a, there are 4 values. B, there are only 3, that means there is one missing on the B column. C, there is one more missing, again one missing in the C as well, right? Because there is one NN, right? For D there is nothing, so all full data. So this kind of information will help you. df2 dot describe is another function. Okay, I hope you guys will explore these functionalities, different functions, and come up with your observations. So describe will give you some basic statistical calculations, like count how many values you find. 4 in the A column, but 3 for C and B. and 4 for D. So for these 4, it takes the average, that is mean, then the standard deviation, then the minimum value, then the maximum value, then 25 percentile, that is first quartile, the second quartile, and the third quartile. Okay, the 25 percentile is the first quartile, 75 percentile is the third quartile, and 50 percentile is your median. So the middle value. So we have these things. So in the upcoming sessions we will be discussing the basics about the statistics. I will explain more about these things that time, but for now the describe function does this for us, all the numeric values calculated. So info functions gives me some quick information about the type of the data which we hold, and the missing if there is any missing information. Okay, so we have learned about how to fill a particular column, looking at fill NA function for that particular column. Okay, if you use df2 dot fill NA, and if you use just some value, let's say 100, it does directly fill all the values. Okay, but remember those values are not reflected unless we actually assign this back to the same data frame. So right now we still have the same. Okay, but there is also a provision to drop. Okay, so df2 dot drop NA. Okay, if you do that, and see what happens, it has just dropped those rows where it finds at least one NaN. Okay, but this may not be the good idea, right? Sometimes we may want to drop the column if we have lot many missing for a particular value, right? Suppose C, for C feature we see that there are 3 places the value is missing, so it doesn't make sense to drop 3 rows. Instead we should just drop the column, right? So that is also possible. Remember, after this there is no change in the function, in the data frame, so we still have the same data frame, but here we can just provide axis equal to 1, so that this will be applied on column and not the rows. Okay, so axis is a argument. How to check that? There is a help page. You can write, you can use this shortcut shift tab on that function. That function's help will be given. Axis is 0 by default, and it indicates that if you are working on rows, and sometimes you may want to work on columns, so axis value should be 1 in that case. Okay, that's what we are trying to explain here. Still your data frame is no change, right? So I'm not purposely changing it, because I just wanted to show you how drop NA works, in this case, and I'm using the same data, and I'm showing you how to fill up all the data. We filled up here, but the actual data frame is not updated. That's why I can use the same data frame to drop the NA values as well. Okay, so that's a simple thing. I will use the same variables earlier whatever we have used. So it is now showing you a numpy data. It is df2, correct? So df2, it's a 4 by 4 matrix, which we can see here. Okay, we have similarly so many functions which you can check with this particular data frame as well. There are 4 columns. Okay, so now I will take you to the next level, where we would like to discuss something about the data which you already have, data frame that is in the file. We will see that, but let me also show you before that. If I want to drop a particular column, okay, not necessarily that column should have some NA, right? Suppose even if it is there or it is not there, so df2 dot drop. Okay, so there is a provision to drop something. Okay, and we can drop a particular column, let's say D. Okay, and axis equal to 1, because I am trying to drop a column. And look at this, the column has been dropped. Okay, so the column gets removed, but that is not reflected back to the data frame. If you see df2, still there is a D. So to make this change take place then and there in memory, so drop function also have a provision to use one more argument, that is in place equal to true. Remember, this in place and axis we are going to use with multiple functions. I hope you understand what is axis. Axis 1 means whatever we are doing with this functionality will be applied on the axis, that is axis 1, that is column. and in place equal to true means whatever you are doing, it should happen within the data frame then and there itself, right? So it should take effect immediately on the same data frame. Earlier it was not happening, right? You drop this, but dropped output was displayed here. Your original data frame was not getting changed. Okay, see, original data frame still had D column here, but after drop with input equal to true value argument, your D got removed. Correct? So that's how we can use this couple of important arguments to drop function, and those arguments we will be probably using going forward for many other functions as well. Okay. Okay, so this is about this particular data frame, and we have tried and saw how we are using the data frame and performing some basic operations. Okay, so let me do one more thing. Let's say I want to read a data frame using a CSV file, right? Let me see if I have home/gbure/data/ there's a Titanic data set. I think, yeah, it is there. Let me see if I can see something. Okay, I can see that. Okay, this is the data set you will find on various public portals, like Kaggle is one. I will be explaining about Kaggle sometime later when we discuss the core data science stuff, right? On Kaggle, this is a public website where a lot of data science related courses or discussions or the assignments or challenges are given there. You get new data sets related to, let's say, COVID-19, or your old data sets like Titanic information, where this particular data set has passengers from the Titanic, and you see the passenger ID, whether that passenger has survived or not survived, what is the passenger class, the name of the passenger, sex, the age, the sibling information, a PR, the ticket information, fare, cabin, right, and embarked, from which port the passenger was embarked. So this is some of the common and useful information, right? And suppose we got this information and want to analyze it, understand what is happening, right? So what all things we could do? Let's try and explore and understand with the help of this particular data set. I am trying to explain you the functions. Let's not focus more into the data set, but here my interest is to show you how we can use some of the operation, we can do some of the operations on a data frame, right? How to use some of these functionalities in the data frame. Okay, so let's try and apply some of them. Let's say df dot age, a capital, right? You see, you get lot of age information here, right? So df dot age, if it is greater than 60, let's say, yeah, true and false, something of that sort it is printing. Okay, now suppose if you put this like this here, df, and you will see the records where the age is greater than 60 years. Okay, that's all, right? It's a simple I think similar things we have done for NumPy. We have provision to use the conditional expressions inside the script operator, right? So we can do that along with the slicing concepts. So we can check how many passengers whose age is greater than 60, right? And we get the answer is totally 22 out of how many total. We can check the length using alien. So out of 891 passengers, there are 22 passengers whose age is greater than 20. And look at the age here, 66, 65, 71. So every age is greater than 60. Okay, you could think about using 65 then, and check how many are there, right? So they are around 8 now, right? This time it is 8. Only 8 passengers whose age is greater than 65 are there. And now I want to check how many of them are survived. Okay, unfortunately only one was survived out of 8, okay, whose age is greater than 65. So such option is also possible here, as we have discussed earlier. So df dot age, not age, it is survived this time, right? Survived, if it is equal to 1. Okay, there's only one passenger who survived out of 8. okay, whose age is greater than 65. Okay, so such kind of important aspects we can do. Similar example to take is suppose greater than 60 and who survived is total 5 5 out of 22, right? Or I would say greater than 60 and who is female. Okay, and check there are 3 female passengers whose age is greater than 60, and there are 19 female passengers, of course, because total are 22. Those are male passengers whose age is greater than 60. Okay, so that kind of basic stuff, the things we can perform using data frames. Okay, we have just used one file, and we can also explore. Let me just move back to female just to make it visible in a single screen. Now let's try and see how we can use some other functions on this particular series, or I would say df.embark is nothing but a series because we are talking about only one column, and we can use a function called, let's say, unique, to see how many unique ports from where the passengers were embarked. Okay, obviously S, C and Q, these are the 3, but there is NN as well. That means there was one or many passengers who have not provided this information. In fact, that is missing. For example, this one. Okay, that is missing. So the information is missing. That doesn't mean there is another port, right? No, there are only 3 ports from where passengers were boarded. There might be 4th, we don't know, right? But the passenger who have not filled up, so maybe he or she is boarding or embarking on the Titanic from a different port, which information is not provided, or from the same one of these 3 ports. Okay, but since it is missing, we don't have any provision to find out, so we can just skip those or remove those information, or randomly put some of the existing ports. Okay, if you want to fill up that. Okay, so that's how the basic things. Now let me also explain and try to help you understand with the help of the data frame is null information, right? If I run this is null, right? Is there any null information? Yes, there is. Wherever it is missing, it will show you whether there is any missing information or not. Okay, so dot any, let me see if I can get something. Access equal to 1. Yeah, we are also getting the true or false, so that's okay. I think we can let me try whatever is missing, and we can see that wherever there is a missing information, at least something is missing. So for example, cabin, here lot many cabin information is missing, so all those are now printed. Okay, at some places cabin information is not missing, for example here, but something else is missing for sure, right? That is here, age. Okay, so is null means it will just find anywhere. If it finds null, we are now going to display that. Okay, you may need to see that. Okay, so it's just an option, but you can think about using this. Okay, so let me also get you some basic operations which we may want to work on to get the details, right? For example, df dot name. Okay, we can print. There are a lot many names we got printed, right? But sometimes we want to apply some string functionality. So here str, so any series, that means any data frames one column, when you want to access, you just use str, and then after that you can access, you can use all the string functions. Okay, that means names are getting converted to capital letter, right? So now you can just check name equal to, and now after that df dot head, this will give you, okay, by the way, head is another function which gives you the top 5 rows from your data frame. Okay, so yeah, this gives you a quick view of your data frame. Generally we look at first few records to just make sure that we are having a proper structure and information present. The str function has converted your names to uppercase, right? I think you have observed that. Okay, so that's how we can use these functions, and we can work out. So there are so many such functions. You can check the different options, what all things you can check, you can use, you can apply, so that we can perform over this particular data frame. Okay, so let me also show you or help you understand how to get the length of a data frame. I think we have checked that. So length is 89, and now df dot info. Okay, this is a very quick and brief view about your entire data frame. You see passenger ID, survive, P class, everything looks good, but age number is 714. That means so many age information is missing. So cabin information is 204. That means so much of information is missing here. Out of 891 records, only 204 passengers have provided their cabin information. Okay, or somehow it is not present for rest of the passengers. Okay, and the data type is all integer, or float. Wherever you see object, that means it could be a categorical information. That means it is a string, it is not a numeric data. Okay, anything other than numeric is treated as an object, because in using pandas or numpy going forward, when we want to convert that, it should be numeric data always, right? There are different ways to convert this. We will be looking at some of the ways later on for converting your categorical into the numerical data. So obviously you know that ticket and the cabin and embarked, these are not the numeric data here. Okay, where is the name? Yeah, name is also right, name and sex. So these are three important 4 or 5, I think, right? 5 objects which is of type no, other than numeric. Okay, and we also seen that describe is a function which gives you the basic mathematical statistical calculations about your data frame, and that works only with the numeric data. Obviously the name is not considered here. Okay, so yeah, this gives you a brief understanding about a basic data frame, what data frame is, what is series, and how to access some of the the attributes or some of the data from your data frame. So in the next video we will discuss something more about some more functions, like how to merge, how to concatenate, how to join, right, or how to group by. So those are some of the important functions which is very useful when we want to do data exploration. But this basics is really important. I want you guys to practice each and every topic here, every cell or every function which we have tried. Quite basic thing, but very information, very useful. You should be very hands-on with this. So I suggest go through this notebook once again, type by yourself. That gives you little confidence about how we are working with the various data frames. Okay, thanks for watching. We'll see you in the next video.